So here we are, section 5.3. This is a concept that's kind of confusing for students generally. And what we're being asked to do is we're asked to find, let's see, that's an inverse notation. And that thing right there would be a derivative. So we're being asked to find the derivative of an inverse function at a value or at a point. And what I'm trying to do with this lesson is try to get you set up so that you could follow the pattern and then try to use that to justify a shortcut conclusion. So that's what we're going to try to work for. So I'm going to try to do the inverse part in blue, and I'm going to try to do the original function part in red. Now, before I start, that's a square root. I see no symbol right there, which means that this square root is always going to turn out positive. So if my y's are always positive, that must mean my range is 0 to infinity. Now, I point that out because when I come over here to do my inverse, swapping x and y, and I solve for y, well, y is going to be equal to x squared. Well, x squared is a parabola that would be opening upward. That's not a one-to-one function. Since it's not one-to-one, we'd have to limit the domain. Well, what's the domain we're going to use? Well, since the range of this one is 0 to infinity, that must mean our inverse function is x squared, but we're going to use the domain of 0 to infinity. We're only going to use the positive values because of the range of that original function. Okay, so here's my inverse. We know we're only using positive x values. I've got my original function sitting there, and what I want to do is I want to just fly through a few of these values to show you a pattern. So let's start with some red. So red, f of 3. F of 3, square root of 3. F of 36, square root of 36 is 6. F of 100 would be 10. So there's some points. So on f of x, on the function f of x, we have 3 points. We have 3, oops, not 3 root 3, 3 root 3. We have 36, 6, and we have 100, 10. Those are 3 points that would be on the f of x function. Okay, so let's come over here and let's look at the f inverse function. Okay, so f inverse of root 3. Well, that's going to be root 3, and I'm supposed to square it, so that's going to be 3. This one, 6 squared would be 36, and 10 squared would be 100. So what we found here is that on f inverse of x, I've got the point root 3, 3, 6, 36, and 10, 100. Now, I did that so that you can see patterns, okay? The x value of one is y value of the other. We already know that based on what we know about inverses. So now how does that play out? Is there a relationship between the derivatives? What kind of a pattern have we got going here? So I've got these values. I'm going to look back at them in a second. So you'll notice as I scroll down, here's in letter C, we were doing f inverse of root 3, and in letter G, we're doing f inverse prime of root 3. So f inverse prime of 6, f inverse prime of 10, I'm using the exact same values. So now what does that mean? So let's find f prime of x. So f prime of x, going back to red, so that would be 1/2 x to the negative 1/2 power, or 1 over 2 root x. So let's find some values. F prime of 3, 1 over 2 root 3. F prime of 36, 1 over 2 root 36 would be 1 over 2 times 6, 1/12. F prime of 100, 1 over 2 times 10, which would be 1 over 200. Okay, so we found our derivative values at those points. Okay, so f inverse prime then. So f inverse prime. So f inverse is x squared. So f inverse prime would be 2x. And again, we have to remember that we're only using positive x values because that domain. So f inverse prime of root 3 would be 2 root 3. F inverse prime of 6 would be 2 times 6 is 12. F inverse prime of 10 would be 20. Okay, now my question down at the bottom of the page is, what do you notice about the results of parts F and G? Well, I notice that in every one of these cases, I've got 1 over 200 here. Whoops, I wrote 20 and I meant 200. Here's your relationship. Okay, what do you notice about each of these? I'm hoping that you notice that these are each reciprocals of each other. Well, what did those points have to do with each other? So on the top of the screen, you see the point on the red one. You had the point 10 or 100, x value, 10, y value. That derivative at 100 turned out to be 1 over 200. The blue one had the swapped x and y coordinates. The derivative turned out to be the reciprocal. So what have we got going there? We've got something about a reciprocal going on. We've got a reciprocal between derivatives. All right, so going to the second page. So second page, same basic idea. We're going to set this up, and you'll notice I created some things here. I'm looking forward to H and to number 3 because those are the ones where we're going to try this relationship between values and see what we can come up with. So let's start. We've got f of x. F inverse of x, we're going to swap our variables. X is equal to, let's see, so 2y cubed. So x over 2 would be equal to, let's go with thinner pen, y cubed. So that would mean that my f inverse of x would be the cubed root of x over 2. So there, and that's a one-to-one function already, so we don't have to worry about one-to-ones or domains and things like that. So there's my inverse. So same thing. F of negative 1 would be 2 times negative 1 would be negative 2. F of 10, 2 times 10 cubed, 2 times 1,000 would be 2,000. So here we are again. On f of x, I've got the point negative 1, negative 2, and I've got the point 10, 2,000. So I can either go through all of the analysis, because according to part C, I'm now supposed to do the same thing with my answer to part B, letter I, which was right here. So I'm really doing f inverse of negative 2. Well, what's f inverse of negative 2? Let's see, put negative 2 in here. That would be negative 2 over 2, and I'm supposed to do the cubed root of that. So that would be the cubed root of negative 1, or that would be negative 1. So what have we found? On the inverse, I've got the point negative 2, negative 1. Now, according to what we said before, we knew that was going to happen. Okay? Now, in II here, we're supposed to do our answer to part B, 2. Well, that would be this 2,000. So f inverse of 2,000, I'm not going to do any analysis at all, because if I did this right, that 2,000, that's going to turn out to be 10 because of this letter right here, or that number right there. So on f inverse of x, I know I've got the point 2,000, 10. So again, we're using this, we're going back and forth. We're ultimately trying to figure out f inverse prime of those values. And down here, you'll notice I threw in a 250 that had nothing to do with anybody. So let's see what happens with this. So f prime of x. So we'll take our derivative, go back to red. This would be 6x squared. F inverse prime of x. This is going to be a little more of a challenge. So that would be, let's see, how about 1/3 times x over 2 raised to the negative 2/3 power, multiplied then by a 1/2, or I think I'd have a 1/6 times x over 2 to the negative 2/3 power, and that just looks nasty. If you wanted to take the negative out, you could just flip the 2 and the x upside down, so 1/6 times 2 over x raised to the 2/3 power. All right, so that is a terrible derivative. So here's your f inverse prime of x. Okay. Letter F. F prime of negative 1. No big deal. That's 6 times negative 1 squared. 6 times 1, that's 6. 10. 10 squared is 100 times 6. That's 600. Okay, so F inverse prime of your answer to part B. So we're going all the way back up here to part B, and we're going to use that number right there, that negative 2. So we're trying to find F inverse. Whoops, sorry, I wanted to do that in blue. So let's get that out of there. So F inverse prime of my negative 2. Well, I can go here and I can do, let's see, that's 1/6 times 2 over negative 2 to the 2/3 power. 2 over negative 2 would be negative 1 to the 2/3 power. Negative 1 to any power is going to turn out to, well, squared, it's going to be positive. Cube root of a positive is going to be positive. That's going to turn out to be a 1/6. Interesting. 1/6, 6. Now, when we go to take this 600 and plug the 600 in there, this one we're supposed to do F inverse prime of 600. Sorry, not of 600. We're supposed to do F inverse prime of our 2,000. So that, I'll bet you, if I just save myself some time, that's going to turn out to be 1 over 600. Let's make that clearer. That's going to turn out to be 1 over 600. Bam.